Assalamualaikum. This is lecture 5 of software requirement engineering, and in this lecture I am going to discuss the analysis techniques for the requirement specification documents and important considerations for the negotiation before stipulating the final software requirement specifications. And after that, I will discuss some characteristics of the requirement specification or requirements statements, that how you are going to write your requirements in a formal way. Let's start with the discussion of the requirement analysis. And the requirement analysis is a continuous process is which is spread over the whole software development life cycle. And the aim of the requirement analysis is to discover problems with the system requirements, especially incompleteness and the inconsistencies between the requirements. So some analysis is interleaved with the requirement elicitation techniques when you are actually gathering the requirements, as problems are sometimes very obvious as soon as a requirement is expressed by your client or other stakeholders. So detailed analysis usually takes place after the initial draft of the requirements, when your final SRS is produced. So requirement analysis is an iterative process, and it deals with the different sub-processes of the requirement elicitation process. So at the start of the requirement elicitation process, you collect the requirements from the stakeholders, and then you draft those requirements in some form of formal language. And the requirement analyst performs the requirement analysis at this stage to identify any problems for incompleteness and inconsistencies. When the problems are accessed, there is a remedial process applied. And then after the solving of those problems, the requirement negotiation phase is started, which we will discuss in upcoming slides. And finally, you produce a requirement document after the negotiations with the relevant stakeholders. So here are some comments that you have to keep in your mind when you perform the requirement analysis process. So if you are an analyst, you read the requirements, you highlight the problems and discuss them in the requirement review meetings, and these meetings should be carried out with the relevant stakeholders. So this is a time consuming and expensive activity, because most of the requirement engineers are your senior people or people with the authority, and when those people spend time on such activities, you have to pay them in a very higher amount, and therefore this activity makes itself very expensive. However, on the other hand, it is very important and vital to remove errors from the set of requirements at this stage, because you want the early error detection and early prevention of the errors to avoid any foreseeable errors in the future. And this will directly result in saving the time and the money in the future. However, it is not possible to make this activity a structured and a systematic process, because it involves people thinking and involves the perception of the requirement engineers. So what do these requirement engineers or analysts have to find errors? Typically, analysts have to think about the implications or effects of the draft statements of the requirements to analyze those requirements and identify the errors. As described, it is more related with the perception of the peoples, and different people may think about the same problem in a different way, and different analysts tackle the process in different ways as well. So the analysts are bound to have a disagreement when the requirement team within the requirement teams. It is the responsibility of a team manager to come up with a concept and environment that they can work together. So this process depends on the judgment and the experience of the process participants. The more mature or more senior the participant, it more likely it is for them to find the errors and correct them at the earliest as possible. So it requires a lot of effort to make this process as objective as possible. The manager of the requirement engineering team has to play a very significant role in managing people and managing their disagreements and employing a strategy so that they can work together. So requirement analysis it consists of different stages, and in the first stage you check the necessity of the requirements, and in the second stage you check the consistency and the completeness of the requirement, and in the third stage you check that whether these requirements are feasible if you try to achieve those. So as described in the first phase, you check the necessity for the requirements, and it is the need for the requirement which is analyzed in this stage. So in some cases, requirements may be proposed which do not contribute to the business goals, or it may have some irrelevant requirements. Therefore, necessity checking is performed, and requirement engineers should target the business goals of the organizations with the requirements. So here the requirement engineers use their analytical power, professionalism, and other inherent qualities. So sometimes the customers also want to include everything in the software product which they do not need. Therefore, you have to check the necessity for those requirements. So you have to analyze in context of budget, schedule, technology, and conformance to the objectives of the clients or the business goals. Once the necessity of the requirements has been checked and only those requirements which meet the necessity requirements are carried forward, the next phase in the requirement analysis is consistency and completeness checking. The requirements are cross-checked for consistency and completeness. Consistency means no requirement should be contradictory and no requirement should overlap with each other. On the other hand, completeness means that no services or no constraints which are needed have been missed out. So once the requirements are consistent and complete, you perform the feasibility checking phase in the analysis of the requirements. In the feasibility checking phase, the requirements are checked to ensure that they are feasible in context of budget, schedule, and technology available for the system development. So a requirement can come from a customer which may be correct with regard to its role towards the business goals, but it may require huge amount of money to implement or may want a technology which does not exist. Therefore, feasibility checking will fail and you will be less likely to proceed with those requirements which are not feasible to achieve. So there are several techniques used for analysis of the requirements, and two techniques which are most commonly used are available to us, and we can apply both or any single technique from these two. The first is the simplest technique which has the number of checklists for the analysis, and a checklist is a list of questions which analysts may use to assess each requirement. The second technique is slightly complex than the first technique, and it involves the inclusion of interaction matrix. interaction metrics are used to discover interactions between requirements and to highlight conflicts and overlaps. So we will look at both of these techniques briefly, and the first is the analysis checklist. And in checklist, each requirement may be assessed against the checklist items. So when a potential problem is discovered, it should be noted carefully, and they can be implemented as a spreadsheet where rows are labeled with the requirement identifiers and columns are labeled as checklist, and you have number of requirements and you check each item if any requirement match with the checklist items and cross if it does not match with the checklist items. And they must evolve, sorry, they are useful when they provide a reminder of what to look and to reduce the chances that you will forget some requirement checks. They must evolve with the experience of requirement analysis process, and the question should be general rather than restrictive, which can be irrelevant for most systems. So checklist should not include more than 10 items because people forget items on a long checklist reading through a document. So here are some example checklists. For example, you can check for the premature designs, combined requirements, unnecessary requirements, use of non-standard hardware, conformance with the business goals, requirement ambiguity, requirement realism, and requirement testability. We will discuss briefly each of these examples. So first of all, if you have a checklist items called premature design and you want to check your requirements with this checklist item, and it does the requirement, it questions that the requirement include premature design or implementation information. So if the answer is yes, highlight it to the customers and try to exclude it from the requirements. If you are looking for the combined requirements, it checks that the description of the requirement describe a single requirement or could it be broken into several different requirements. So if the answer is yes, then break it down into several different requirements. Otherwise, go with it with the single requirement. So that will help determining the consistency and the completion aspect of the requirement set. You can also check for the unnecessary requirements, and you can ask question, is requirement necessary? That is, the requirement is a cosmetic addition to the system which is not really necessary. So you can also check for the use of non-standard hardware, and in this means that the requirement meets the specified hardware or software to be used, and if it does not comply with the standard use of hardware, you can exclude it from your document. The conformance with the business goals is another checklist item, and in this item you check requirements with the consistency of the business goals and the requirement specifications. And if requirements do not match the business goals, you can exclude from the requirement specification documents. You can also check for the requirements ambiguity, and if the requirements are ambiguous, you can remove these requirements as early as possible. In the requirements realism, you check that the requirement are realistic given the technology which will be used to implement the system. It is much more relevant to the requirement feasibility step. And finally, you can also check for the requirement testability, in that you can ask that this requirement is testable, that is, if it is stated in such a way that the test engineers can derive a test case which can show if the system meets that requirement. So the second requirement analysis technique is the requirement interaction matrices. So a very important objective of the requirement analysis is to discover interactions between the requirements and to highlight the requirements conflicts and overlaps. So we can use the requirement interaction matrix which show how requirements interact with each other and which can be constructed using a spreadsheet. So each requirement is compared with the requirement and the matrix is filled, for example, as follows. So if the requirements conflict with each other, you fill the matrix with 1. So if the requirements which overlap with each other, you fill it with 1000. And if the requirements are independent, you fill with a 0. So here is an example of interaction matrix, and we have uh, 6 different requirements for a system, and we map these requirements with the interaction matrix example discussed in the previous slide, that if the requirements are independent, we fill with a 0, and if requirements overlap, we fill with the 1000, and if requirements conflict, we fill with the 1. So as you can see, number of requirements have been filled, and requirement 3 overlaps with the requirement 1, requirement 4, and requirement 6. So these kind of requirements have very high percentage of chances to be removed in the requirement analysis phase. So the rest of the requirements have only one conflicts, for example requirement 1, 4 and 6 again confirm with the requirement 3. So if you remove the requirement 3, you will have a very least amount of requirement conflicts and overlaps. So as you can see, requirement 2 is one of the requirements that is independent of all other requirements, which should be done on the priority basis. You have to be very careful when filling the interaction matrix for the conflicts and overlaps. And if you cannot decide that the conflict exists, you should assume that it exists rather than specifying that it does not exist. It will help you to be on the safe side, because if an error is made in the writing conflict whereas there was no conflict, in reality it is usually fairly cheap to fix. On the other hand, if there was conflict and you missed it to write it, and it will be very difficult to fix in the later stage. So in the example we are considering, you can see requirement 1 overlaps with the requirement 3, 5 and 6, and requirement 2 is an independent requirement. Requirement 3 overlaps with the requirement 1, 4 and 6. The advantage of using the numerical values for the conflicts and overlaps is that you can sum each of the rows and columns to find out the number of conflicts and the number of overlaps. So requirements which have high values for both of these figures should be carefully examined. A large number of conflicts or overlaps means that any changes to the requirement will probably have a major impact on the rest of the requirements. Interaction matrix work only when there is a relatively small number of requirements, as each requirement is compared with every other requirement, and usually the upper limit for this case is 200 requirements. The benefit of interaction matrix is that these overlaps and conflicts can be discussed and resolved during the requirement negotiation meetings, which we will discuss next. So this leads us to the discussion of requirement negotiation techniques. So there are always more than one stakeholders in any organization or any business endeavor. So disagreements are bound to happen about the requirements. So you cannot avoid these requirements when a system has many stakeholders. For example, access of data is in a distributed system will have certain implications. For example, one requirement says that the access or to the data to be given to authorized security staff only. Other requirement says that the technical managers of the distributed site will also be given access to the data, which will create a requirement conflict. So conflicts are not failures, but reflect different stakeholders' needs and priorities. So requirements negotiation is the process of discussing requirement conflicts and reaching a compromise that all stakeholders can agree to. So sufficient time must be allocated to this crucial activity. In the planning requirement engineering process, it is important to leave enough time for negotiation of the requirements. So finding an acceptable compromise can be time consuming because you have to cater the needs of different stakeholders and you have to ensure that they are on the same page and any conflicts and disagreements are solved in time. The final requirements will always be a compromise which is governed by the needs of organization in general, the specific requirements of different stakeholders, design and implementation constraints, and the budget and the schedule for the system development. These are the parameters which limit the scope of agreed set of requirements, which obviously have to be negotiated set of requirements and large number of stakeholders have to agree with it. So there can be different kinds of conflicts between the stakeholders. For example, conflicts can exist between the suppliers and the customers about costs, benefits, and the risk of the requirements. It can be a power struggle within the customer organizations or conflicts with the other projects and about the resources. It can be conflicts about the goal, features, and the requirements of the product. Conflict resolutions involve negotiation techniques as a primary tool. Negotiations Negotiating a coherent set of requirements is not easy, but it is one of the tasks of the requirement analyst, and it is difficult to satisfy everyone to achieve all goals and make good decisions. Therefore, you have to move towards the compromise which can be done in an acceptable time, budget, and resources. And this negotiation uh, step involves a lot of group discussions to meet a standard goal. So the main step in the requirement negotiation technique is the detection of the requirement conflicts. And first of all, you have to detect when requirements are inconsistent and then convince all the stakeholders to understand the essential point of view of each other. You can do it by conducting meetings with each other and have each party explain what they believe in other party wants and why. Conclusively, reach an agreement that is a coherent set of requirements that meets the needs of as many stakeholders as possible. This can be done by analysis of each party's goals, find solutions that do not conflict but ideally support everybody's goal. So the solution is let the schedule derive the requirements, not the requirements deriving the schedule. So put the time constraint on the requirement analysis techniques. So for example, as you can see in this diagram, a meeting is shown between client and the developers. So they are having a conflict over the time. So take the time factor or schedule factor. as a cardinal indicator to derive the requirements. So here is a better scenario of the schedule in deriving the requirements in which negotiations are applied to make compromises about the requirements which can be done during the specified time. So much like the requirement analysis, there are different stages in the requirement negotiations. So at the start, you discuss about the requirements, then the requirements are prioritized. Finally, an agreement is reached after the negotiation and prioritization of the requirements. So requirements which have been highlighted as problematic or having conflicts are discussed and the stakeholders involved present their views about the requirements. So these discussions must be held in a friendly and a professional manner. So if stakeholders are not free to express their views, then it is quite probable that the set of requirements will include such requirements which will not meet the stated objectives. So when the discussions are done, you move to the requirement prioritization step. And in this step, disputed requirements are prioritized to identify critical requirements and to help the decision-making process. It is a difficult thing to do because you have to identify who determines the priority, obviously by all stakeholders together. However, powerful stakeholders, like in any organization, of course, will have the stronger opinion and stronger influence on the stakeholders. Projects do have some core requirements which must be implemented before any other requirements, but with non-core requirements, the influence of stakeholders matters and the priority is given to the stronger group of stakeholders. So you can categorize these requirements as must-have requirements and nice-to-have requirements. So there are different techniques for the prioritization of the requirement, and the simplest of all prioritization method is to have the group of stakeholders work down a list of requirements and make a binary decision. Is it in or is it out the requirement? So keep referring to the project business objectives to make this judgment, paring the list down to bare minimum needed for the first release. Then when implementation of that release is underway, you can go back to the previously out requirements and go through the process again and then in the next release. You can alternatively develop some prioritization scales, and a common prioritization approach groups requirements into different categories. So if you are using three categories, they boil down to high level requirements, medium level requirements, and low level requirements, depending on the priority of each requirement. So such scales are subjective and imprecise. To make these scales useful, the stakeholder must agree on what each level means in the scale they use. So they use two scales frequently. The number one is urgency and number two is importance. Urgency again is defined in three scales: high, medium, and low. High refers to the mission critical requirements required in the next release. Medium supports the necessary system operations required eventually but could wait until the later release if necessary. Low urgency requirements are a functional or quality enhancement which is nice to have, but if you delay it, it is not problematic. The other scale is the importance, which can be categorized into essential, conditional, and optional. Essential refers that the product is unacceptable unless these requirements are satisfied. Conditional would enhance the product but the product is acceptable if the requirement is absent. Optional are the functions that may or may not be worthwhile. One way to assess the priorities is to consider the two dimensions of importance and urgency. So every requirement can be considered as being either important to achieving the business objectives or not so important. On the other hand, it can be urgent or not so urgent. These alternatives yield four possible combinations which you can use to define priority scales. So requirement in the fourth quadrant appear to be urgent and important, therefore they have high priority. Perhaps for the political reasons, but they are not. On the other hand, if you go to this quadrant, the priority is very low, and if you move to this quadrant, the priority is below the low, and these requirements are not important and these are not urgent. So your focus should be on this part with the high priority and the medium priority. So sometimes, particularly on the large project, you might want to perform prioritization iteratively. So first have a team to rate the requirements as high, medium or low. If the number of high priority requirements is excessive and you are not convinced that they are all really must be delivered in the next release, perform a second level partitioning of high priority ones into three different groups again. You could call them high, higher, and highest if you like, so people don't lose the sight of the fact that they were originally designed as being important. So the requirements rated highest become your new group of top priority requirements, group as high and higher requirements in which your original medium priority group. So when performing this kind of prioritization analysis with the three-level scale, you need to be aware of the requirement dependencies. You will run into problems if a high priority requirement is dependent on another that is ranked low priority and hence planned for the implementation later on. So here is an example of multiple three-level scales. For example, in the first phase, you analyze the requirements and prioritize them as high, medium, and low. And in the second phase, you have only identified the high-level requirements and you again divide it in three different scales as high, higher, and highest. And only highest level of the requirements are considered high priority. The rest three are considered medium priorities and the low is again considered low priority requirements. The third technique for the requirement prioritization is called the Moscow technique. The four capital letters in the Moscow M, S, C, and W prioritization scheme stand for four possible priority classifications for the requirement in the set. The M stands for must requirements, the S stands for should requirements, C stands for could requirements, and W stands for want requirements. The must requirements must be satisfied for the solution to be considered a success. Should requirements are important and should be included in the solution if possible, but not mandatory to the success. Could requirements are desirable capability, but if you do not include these requirements and defer for the later release, you can still go for the successive product development. Want requirements are unnecessary requirements and it will not be implemented at this time but could be included in the future releases. The Moscow scheme changes the three-level scale into a four-level scale. It does not offer any rationale for making decisions about how to rate the priority of a given requirement compared to others. Moscow is ambiguous as to timing, particularly when it comes to the won't rating. Won't could mean either not in the next release or not ever. Such distinctions must be made clear so that all the stakeholders share a common understanding of the implications of a particular priority rating. Another technique is the $100 investment scheme. So prioritization is about thoughtfully allocating limited resources to achieve the maximum benefit from the investment on an organization makes in a product or a project. So one way to make prioritization is more tangible is to cost it in terms of actual resources, for example, money. So give the prioritization team 100 imaginary dollars to work with, and team members allocate these dollars to buy items that they would like to have implemented from the complete set of candidate requirements. They weight the higher priority requirements more heavily by allocating more dollars to them, and if a requirement is 3 times as important as a stakeholder as another requirement, so they would assign perhaps $9 to the first requirement and $3 to the second requirement. But the upper limit is the $100 and they have to invest $100 on all the requirements. So when they are out of money, nothing else can be implemented, at least not in the release they are currently focusing on. So one approach is to have the different participants in the prioritization process perform their own dollar allocations and then add up the total number of dollars assigned to each requirement to see which ones collectively come out as having the highest priority. So prioritization can be based on cost and the value. So you can calculate the return on investment by assessing the value of each requirement and the cost of each requirement. And then you can calculate the cost value trade-off. However, there are difficulties in the techniques based on the cost and the value analysis. Sometimes it is hard to calculate absolute value of the requirement or actual cost performed on a single requirement. So relative cost value figures are easier to obtain. Interdependent requirements are difficult to treat individually, and there are inconsistencies or conflicts in the priorities assigned by the individual stakeholders. Therefore, another technique based on the cost and the value um, is called the Wiegers prioritizations. It is a semi-quantitative analytical approach to the requirement prioritizations based on the value, cost, and risk. It relies on the estimation of relative priorities of requirement dimensions. There are different dimensions, for example, relative benefit, relative penalty, relative cost, and relative risks. Benefits specify if you have the requirements, what will be the benefit of your product. Relative penalty to the stakeholders specifies if the requirement is not included, what harm it can put on the stakeholders. Cost specifies the cost to implement the requirement, and risk specifies the technical and other risk associated with the requirements. So each dimension is given a value scale between 0 to 9, and dimensionals have relative weights. And finally, the priority is calculated by the following formula. So you calculate the value percentage and divide it by the cost percentage multiplied by the cost weight plus the risk percentage multiplied by the risk weight. This provides a better overview of the prioritization of the requirement, but it is still limited by the ability to properly estimate. As we have specified, it is difficult to identify the cost for each requirement or the benefit for each requirement. So it requires some adaptations and calibrations of the values. So here is an example done for the chemical tracking system, and we have number of features identified named from 1 to 10, and there are different requirements. So first we have identified the relevant benefit from each requirement, and we have specified the weight as 2 for the relevant benefit. The relative penalty have the weight 1, and it is identified for the each requirement. If that requirement is not included, what harm it can produce over the stakeholders. The total value is summed by multiplying each of the value with its weight and adding each other. The value percentage is found out by dividing the value by the total value and calculating the percentage. Similarly, cost and cost percentage is identified, risk and risk percentage is identified, and conclusively, priorities are identified by using the formula of the value percentage divided by cost and risk percentage multiplied by the weights. Another technique is called pairwise comparison and rank ordering prioritizations. People sometimes try to assign a unique priority sequence number to each requirement. This is the rank ordering of a list of requirements, and it involves making pairwise comparisons between all of them so you can judge which member of the pair has the highest priority. So performing such comparisons becomes unwieldy for more than a couple of dozen requirements. So it could work with the granularity level of features, but not for a all function requirement on the system as a whole. So it is useful if you have very limited requirements. So in reality, rank ordering of all the requirements by priority is very time consuming, and you won't be implementing all these individual releases. Instead, you will group them together in batches by release or development time box. Grouping requirements into features or into small set of requirements that have similar priority or that otherwise must be implemented together is sufficient. So as we specified earlier, it is very difficult to find out the scores and weights, and these are very subjective measures, and you have difficulty in quantification of these measures into some numerical values. However, there are some potential solutions, such as you can make the pairwise comparison that which requirement A or B is more important by comparing A is greater than B, equal to B, or A is less than B. It provides certain benefits, and for example, it can indicate what is important to the client, identification of the requirements on high value and low cost, priority, and identification of the requirements of low value and high cost which are likely to be removed. So it has been already used to assess numerous corporate and government decision makers. Therefore, it is a tested technique. Choosing a telecommunication system, formulating a direct policy, or choosing a product marketing strategies are some of the examples of pairwise comparisons. So it is suitable for large number of pairs. Pairwise comparison can be tedious if your problem is exponential. However, these problems are can be solved by using the mathematical properties such as transitivity and other. Mathematical optimizations of number of pairs can be considered to solve these problems. However, there are many dependencies between the requirements, and you can actually use these requirements dependencies to reduce the number of pairs. For example, you can group many requirements as one features, or you can use use cases or services. One common approach is in this pairwise comparison is called analytical hierarchy process. So this leads us to the sixth technique for the requirement prioritization, and it was developed by Carlson and Ryan based on the work by Seti in early 1970. So it uses the cost value diagram to analyze and discuss the candidate requirements. This requirement is useful for requirement triage and release planning, but also applicable in many other situations where complex decisions to be made. The basic procedure for the rating of set of criteria is you first have to develop pairwise comparison matrix for each criterion, then normalize this matrix, and then find out the average value for each row to get the corresponding rating. The criterion ratings are then used to evaluate the different potential decisions. So you can specify different kinds of ratings. For example, you can use the number 1 if two requirements are equally preferred, number 3 if one is moderately preferred over other, number 5 if the requirement is strongly preferred over the other, 7 very strongly preferred, and 9 if requirement 1 is extremely strongly preferred. So as you move down the order of the number, the requirement priority is higher than the lower number. So values 2, 4, 6, 8 represent the preferences halfway between the integers on the either sides. So once the criteria is specified, then you have to specify the rules to compare to requirement. So suppose you have two criteria, cost and quality for product A and B. The cost for A is $60 and the quality is above average. The cost for B is $15 and the quality is right at average. So which product do you choose? So you make a pairwise comparison between product A and product B. So as you can see, the cost of A is $60 and the cost of B is $15. So which is 4 times greater than B. So if you pick B, you have 4 higher level of the preference. So 1, 3, 5, 7. So you have preference of choosing the product B over the A. So if you choose, if you take the cost in the reverse preference, similarly, it will have, if the product B has the cost of quality of 1, then the chances of picking B is higher because in the reverse order the fraction value will be less. Similarly, if you look at the quality, the difference between both quality is above average and average, that is one step. So again, if the quality of the product A is 3 and the quality of product B is 1. So on the basis of quality, you pick A, and in the reverse direction, you pick the product A. So suppose you have three products with the following pairwise comparison. The product A, B, C each have different criteria. So in the first step, we specified that you have to normalize the matrix and you have to first add each matrix to find out the sum of each column. In the next, the values of each column are divided by the corresponding column sums and the each value is then added up to 1. So as you can see, 11 by 6 is divided with the column A for all of the values. Similarly, 9 is divided with the B and 16 by 5 is divided with C. So in the next step, average the value of each row to get the corresponding rating. So as you can see, the fractions are transferred into decimal point values and which are uh, taken average with the total values. For example, there are three values to find out the priorities for each requirement. And finally, you get the values with the row average, which is the first row has the highest priority. That means the product A has the highest rank to be chosen. So once the requirements are prioritized, the final task in the requirement negotiation stages is the requirement agreement. Solutions to the requirement problems are identified and a comprised set of requirements are reached finally. Generally, this will involve making changes to some of the requirements. So in principle, requirement negotiation should be an objective process and the judgments of the requirements for the system should be based on technical and organizational needs. Reality is, however, often different. Negotiations are rarely conducted using only logical and technical arguments. They are highly influenced by the organizational and political considerations and the personalities of the people involved. For example, on a table, a chief executive and a key punch operator of the same company are sitting, and you can guess who, how much influential will be the CEO. A strong personality may force their priorities on the other stakeholders. Requirements may be accepted or rejected because they strengthen the political influence in the organization of some stakeholders. So there is another problem that end user may be resistant to change and may block the requirement. It's the responsibility of the project manager to control such situations. Negotiation meetings are an important part of the requirement negotiation and analysis phase. So meetings are the most effective way to negotiate requirements and resolve the requirements conflicts. All requirements which are in conflict should be discussed individually and negotiation meetings should be conducted in three stages. In the first stage, you have to provide the information and the stage is called informational stage. So in this stage, the nature of the problems associated with the requirement is explained by the requirements engineer. It is you have to specify that the requirements are overlapping, conflicting, or not feasible. In the discussion phase, the discussion of the stakeholders is conducted during the meeting. The stakeholders discuss how these problems might be resolved. All stakeholders with interest in the requirement should be given the opportunity to speak, and non-influential stakeholders must be included in the discussion and be allowed to express their opinion freely. Priorities may be assigned to requirements at this stage. Finally, a resolution stage is encountered, and in the resolution stage, actions concerning the requirements are agreed. These actions might be to delete a requirement, to suggest specific modifications, or to elicit further information about the requirements. So this leads to the actual definitions of the requirement statements, and the requirement statement should adhere to the certain characteristics such as the requirement should be complete, correct, feasible, necessary, prioritized, unambiguous, and finally verifiable. Complete requirements are the set of the requirements which uh, describe the whole functionality which is to be delivered in the end product. It must contain all the information necessary for the developer to design and implement that bit of functionality. So if you know you are lacking certain information, to be determined as a standard flag to highlight these gaps. So finally, resolve all to be determined in each portion of the requirements before you proceed with the construction of that portion. So requirement should be correct and must accurately describe the functionality to be delivered. The reference for the correctness is the source of the requirement, such as actual customer or higher level system requirement specifications, and only user representatives can determine the correctness of the user requirements. The requirement represent in the client need. Requirement should also be concerned with the feasibility. Feasibility refers that each requirement within the known capabilities and the limitation of systems and its environment. To avoid the infeasible requirement, you have a developer to work with the requirements analyst or marketing personnel throughout the elicitation process. Usually, incremental development approaches and proof of concept prototypes are ways to evaluate the requirement feasibility. Again, requirement necessity is also checked, and each requirement must originate from a source you recognize as having authority or to specify requirements. Trace each requirement back to its origin, such as use cases, system requirements, regulations, and some other voice of the customer input. Priority of the requirement is also an important characteristic of the requirement specification, and each requirement should specify its priority. You assign an implementation priority to each function requirement, feature, or the use case to indicate how essential it is to a particular product release. So if all of the requirements are considered equally important, it is hard for the project manager to respond to budget cuts, schedule overruns, or personal losses, or the new requirements added during the development. Requirements should be unambiguous, and the reader of the requirement statement should be able to draw only one interpretation of it. Natural language is usually highly prone to ambiguity, and there are other effective ways to specify your requirements, such as using a formal language, such as use cases. So you can conduct the formal inspection of the requirement specification. You can write test cases from the requirements to identify errors or unambiguities, or you can create user scenarios that illustrate the expected behavior for the specific portion of the product. So you must also write the requirements which are verifiable and see whether you can devise the tests or you can use other verification approaches such as inspection of formal specification to determine whether each requirement is properly implemented in the product. Requirements that are not so consistent, feasible, or unambiguous are also not verifiable. So if a requirement is not verifiable, determining whether it was correctly implemented is a matter of opinion. Let's discuss some examples of the particularly valid software requirement statements. For example, we have a verifiable non-functional requirement. The requirement states that an operator shall not have to wait for the transaction to complete. So this is a non-quantifiable requirement. You have to change this requirement to a measurable feature. So this requirement can be transformed to a verifiable requirement by stating a quantifiable measure. An operator shall not have to wait more than 1 second for a transaction to complete for at least 95% of the transactions. So here are some examples done for you to check that the requirements conform to the characteristics of requirement statements. So in the first example, we have a requirement that specifies that the product shall provide status messages at regular intervals not less than 60 seconds. So here you can provide quality analysis of the requirement, and after analysis you can find out that the requirement is incomplete because you are not sure what are the status messages and how they are supposed to be displayed to the user. The requirement contains another ambiguous word called regular. So you are not sure how often in the 60 seconds. So showing a new message every 10 years is okay. Perhaps the intent is to have no more than 60 seconds elapsed between the messages. So would 1 millisecond be too short? As a result of these problems, the requirements are not verifiable. Therefore, you can improve the exercise 1 and specify a set of requirements. So as you can see, we have 4 requirements after the analysis, and in the first sub requirement we have the background task manager shall display status messages in a designated area of the user interface at the interval of 60 plus or minus 10 seconds. Again, the ambiguity is removed if the background task is processing the progressing. Normally, the percentage of background task processing that has been completed shall be displayed. The ambiguity or incompleteness about the message is cleared here. A message shall be displayed when the background task is complete, and error message shall be displayed when the background task has stalled. So here is another example. I want you to go through the next few examples to on your own. So here is the end of this lecture, and if you want to read more about the topic, you can go through these references. If you have any questions, you can ask me through any designated medium. Thank you very much.